Hello, my students. Lesson 60, Saxon Algebra 2. Our topic today is direct and inverse variations. Relatively simple idea, relatively simple, excuse me, relatively simple formulas. The math is, students find this relaxing and enjoyable topic. Well, I mean relaxing. That might be a stretch, but you know what I'm saying. Okay, direct variation. If you have ever seen toddlers play, you know what direct variation is. For every child that walks into the room, 85 toys come off the shelf. You know what I'm talking about? They don't just take one and play with it. Each child attacks and gets out a whole bunch of toys. That's called direct variation. Now, I made up this number. They might not get actually 85 toys, but we can build a relationship between how many toys the average child brings off the shelves or out of the baskets or whatever. And we can relate those two numbers, and that's called a direct variation. The important idea is that one child does not equal one toy. One child equals a lot of toys. And we're going to do some problems with this, but I want to introduce you. Well, let's do that problem first before we talk about the inverse variations. Example 60.1. The number of boys in every classroom of a school. Oh, I didn't give you the formula. In our example, boys, B would equal the number of children, and K would be some constant, like 85 in my example, that relates the number of children to how many toys they pull out. So this is the basic formula, and the letters A and B we'll adjust for each specific problem so that the letters represent what it is that we're measuring. Okay, the number of boys in every classroom of a school varies directly as the number of girls. Let me say that again. The number of boys in every classroom of a school varies directly as the number of girls. So we can take that sentence and use that to customize our formula. The number of boys varies directly with the number of girls. I just wrote the letters in the same order that the sentence had them, and that is going to keep me on the right track. In one room, there are 8 boys and 2 girls. Okay, so in one room, the number of boys equals 8, and the number of girls equals 2. If there are 5 girls in another room, how many boys would there be? Okay, notice how I'm jotting this down. I would have flipped the order of that, but it's okay. So we're getting 2 scenarios. The first scenario is going to give us information about the boys and the girls. That will allow us to solve for K. So that's our first step, is to solve for K. That's why we get both of these numbers, because we want to be able to solve for K. So I'm simply going to plug this in. 8 equals K times 2. Right? Boys equals 8, girls equals 2. And now it's a simple matter of dividing. That cancels, and I can say that K equals 4. So that was our first step, is to solve for K. Now we're going to use K to solve for whatever's missing. Okay? In this case, it's the boys that are missing. So we say boys equals, the constant is 4, and the number of girls is 5. So in this case, the number of boys in this classroom must be 20. That's the right answer. It's not that hard, right? The hardest part is trusting yourself to write the equation, and all you have to do is listen to the sentence. I'll read it one more time. The number of boys in every classroom varies directly That's what tells us to be, that's the equals, and then we put the K with the number of girls, okay? That's the hardest part. Let's try another one. I'm going to skip and do example 60.3 because that is the other one that's about direct variation, and then we'll talk about inverse variation or indirect. No, it's inverse, sorry, I always get those mixed up. We'll talk about what that means, and then we'll do the example that relates to that. So 60.3 is talking about direct variation, and it's scary, you guys. The number of clowns was directly proportional to the number of performers. Oh my gosh. Okay, our generic version of this looks like that, so let's fine tune it. The number of clowns is directly proportional to the number of performers. Clowns, performers, I just let the sentence follow the formula. So we're going to have one scenario, and then we're going to have a second scenario. We'll get information about the clowns and performers. This one we'll use to solve for K, and then we'll use K down here to solve for whichever one's missing. If there were 40 clowns, when there were 20,000 performers, oh, that's a big number. How many clowns were there if there were 12,000 performers? Okay, we don't want to just use a simple proportion. We want to use this formula. So we'll use it to start by solving for K. 40 equals K times 20,000. I'll put these in parentheses to show we're multiplying. Okay. Divide both sides by 20,000. And we can see that our answer is going to be a fraction, isn't it? This cancels. I take off 1 0, dividing by 10. And then I recognize that 4, let's see, 2 goes into 4, right? Into 10,000. 10,000 anymore, it's 1,000, right? This 2 turned into a 1, and I have 3 zeros left. I'm just going to rewrite this so we can see more clearly. 1, 1, 2, 3. So it's 2 into 1,000, which equals 1 into 500. I want to reduce that as much as possible. We haven't seen a constant that's a fraction, but that's okay. It can be that way. So now we have K equals 1 over 500. We could write that as a decimal. We could have done it here, right? This would be 0.002. But we're mathematicians. We like fractions. Let's live with it. All right, so now we want to find out if there are 12,000 performers, so we multiply our constant times, whoops, there. Does that make sense? Okay, let's knock off some zeros, which is dividing by 100. And then we have 120 divided by 5. Right? Because we could write this as 120 over 5. That line says divided by 10. And it looks like we would have 24 clowns. And that's the right answer. Make sense? There's our generic formula. There's how we tweaked it. Based on the sentence, the number of clowns was directly proportional to the number of performers. So just let it flow in the same order that the sentence does. Okay, those are two examples of direct proportions. Things are increasing together. One is going up faster than the other, and the constant helps us understand that relationship, but they're both increasing. Let's talk about dads and pizza. The more dads that enter the room, the supply of pizza goes down. I don't think that each dad is only having one slice. I think that for every one dad that enters the room, I bet about 7 slices of pizza disappear. In one piece and being done, are they? So, this is what we call an inverse relationship. Here, I want to make it look like my other one. This is called an inverse variation. And the word kind of makes sense, right? Inverse means things are going opposite to each other, and that's what's happening here. As the number of dads goes up, the pizza's dropping precariously. The general formula, let's just look again. With direct variations, we had A equals K times B. With an inverse variation, A equals K divided by B. So in this case, the amount of pizza slices left relate to the number of dads in the denominator, and this constant, whatever it is, in this case, my guess was that it was 7, that is in the numerator. So it looks a little wonky, but if you remember that with an inverse variation, things are moving. I'm moving my hands in an opposite way. You probably can't see that. If things are moving opposite, it kind of makes sense that you would put them at opposite parts of a fraction. So the process will work exactly the same. We'll be given it'll be a 2-step process. In the first one, we'll solve for K, and then in the second one, we'll solve for whatever John asks of us. But the formula is slightly different, and let's do this. Let's puffy cloud this bad boy. There we go. Okay, so now we're going to go back and do example 60.2, which relates to inverse variations. And then we're done. 60.2. The number of revolutions per minute varies inversely with the number of teeth in the gear. Okay, this is our formula. We want to customize it to our story. The number of revolutions per minute, so I'm going to write RPM for A, is inversely related, varies inversely with the number of teeth. So there's the number of teeth. Let me read it again. You can see I just did it in the same order. The number of revolutions per minute varies inversely with the number of teeth. So teeth goes on the bottom, constant goes there. Cool. Okay, so I'm going to get our first scenario. We're going to be given a number of revolutions per minute and some teeth. We're going to solve for K. And then we'll use that information. I'm not sure which one of these. We'll be given one and asked to solve for the other. And we'll use K to do that. Simple little formula, right? Okay, here come the rest of the numbers. If 40 teeth resulted in 100 RPM, okay, so 40 teeth is 100 RPM. What would be the RPM if the gear had 30 teeth? All right, the numbers are simple. Our formula is right there. Let's go. So 100 equals K divided by 40, right? RPM 100, teeth 40, we're solving for K. Easy, we just multiply both sides by 40. This cancels. K equals 4,000. All right, that's a big number, but it's a simple number. So now we go down here. Again, we're using our same formula, which is right here, our customized one. That's the generic one. And then we customize it to our story. Okay, so we're solving for RPM. RPM equals 4,000 divided by 30. All right, you take off a 0, dividing both sides by 10. And let's do 400 divided by 3. Well, it goes in here once. Get another 1, pull down a 10. Okay, 3 Uh-oh. It keeps going, doesn't it? So I'm going to write my answer like that, and I'm going to say that the RPM equals 133.3 repeating. I checked the book. This is me. John wrote it as 133 1/3. Okay, well that makes sense because what John did is he did this one more time. He got one left, and instead of writing it as a repeating, he just wrote 1/3, right? The remainder over the number on the outside. So his answer is just fine, but I have no need to change it. I like mine better. So I'm happy with that answer. All right, this is the inverse variation. There's a subtle change in the basic formula from the direct variation, but they're both pretty easy to use. Both of them are a two-step process. Lesson 60 is done. Congratulations. We're moving on.